All right, so today we're going to be applying how to solve rational equations. So I've got a couple word problems here, or application problems, everybody's favorite for how to do that. These are very common. You probably see them on the ACT or other standardized testing somewhere. Um, but I think sometimes just knowing how to set them up is pretty difficult. Okay, so we're going to look at a classic example here. Suppose it takes Bob 5 hours to paint a room by himself. It takes Steve 7 hours to paint the same room by himself. How long would it take them if Bob and Steve painted the room together? Okay, so you might look at this like, okay, you just add them up, 5 plus 7, and divide by 2. So it'll take 6 hours. Common answer. Very much wrong answer. Okay, just think about it here. Bob does it in 5 hours by himself. So why would having a friend help him slow him down? Okay, other than the fact that they might be, fooling around or whatever. But you got to think about this. Anytime that you've got two things working together, it should take less time than any one person working by themselves. Um, so our answer needs to be less than 5 hours. Okay, if we don't get an answer less than 5 hours, we did something wrong. Now, to set these problems up, I want us to think of them in terms of rates. Okay, so what I want us to think about here, we've got Bob's rate, we've got Steve's rate, and that's their rate working individually. If we combine those, that's going to be their combined rate, right? Okay, well, how do we write that out? Again, we're talking about rational equations. Rates, okay, rational, okay, that's the same thing here. So if Bob is working for 1 hour, how much of the room does he paint? Well, if assuming he works at a consistent pace, he is working at a rate of 1/5. Okay, he is getting 1/5 of the room painted in 1 hour, right? Because it takes him 5 hours. Well, by that same logic, Steve's rate is 1/7 of the room. Okay, so if you add Bob's rate and Steve's rate together, you are going to get their combined rate, which is 1 over x. They are combining to make 1/x of the room painted in 1 hour. All right. So then we can do that. We can figure this out. That's the equation that we need to solve. All right. Now, based on how I told you to solve rational equations yesterday, we need to multiply by all the denominators to cancel them out. Okay, so we have a 5, a 7, and an x. So that's what we're going to multiply the entire equation by, 5 and 7 and x, to cancel those denominators out. So when we do that, we have 5 times 7 times x over 5 plus 5 times 7 times x over 7 is equal to 5 times 7 times x over x. And as you can see, all the denominators are going to cancel out, leaving us with a very simple problem to solve. 7x plus 5x is equal to 35. Much easier to solve, right? So then you combine your like terms, you get 12x is equal to 35. And when you divide by 12, x is equal to 35 twelfths, or 2 and 11 twelfths, which is less than 5, okay? It's much quicker when we have these two people working together, okay? But that's the process that we need to have here for these application problems. Okay, so if we look at a different one, another example, a bathtub can be filled in 8 minutes. It takes 12 minutes to drain. If the faucet is turned on but the drain is accidentally left open, how long will it take to fill the tub? Now you might be saying, well, if the drain's left open, it's never going to be full. Well, actually, the rate of the water coming in is faster than the rate of the water going out. So it will take time, but eventually it will indeed fill. So again, think of it in terms of rate. This time we're talking minutes instead of hours. That doesn't really matter. But so you've got the fill rate plus the drain rate is going to equal the combined rate. Okay, but the only thing to keep in mind here, this drain rate, what's happening to the water? It's going down. So we actually are going to subtract the drain rate from it. Okay, so our fill rate, the bathtub is being filled, 1/8 of the tub is filled every minute. 1/12 of the tub is drained every minute. So 1/8 minus 1/12 is going to equal that combined rate of 1 over x. Same process as we did on the last problem. We need to multiply the entire equation by all of our denominators to get rid of them. So 8 times 12 times x. So we would have 8 times 12 times x over 8. I don't know why that light is flashing. Minus 8 times 12 times x over 12 equals 8 times 12 times x over x. Wow, okay, lovely. Cancel off your denominators, and you are left with 12x minus 8x is equal to 96, which means that 4x is equal to 96. So you divide by 4, and x is equal to 24 minutes. Forgot to label up here. This should be hours. Don't forget the label because it's an application. Now, you might be thinking, okay, Mr. Sampson, you said up here that it should be faster. Well, yes, if they're working together, it should be faster. That's why this number down here is less than the individual rate. But these are opposing each other. One's filling, one's draining. So it's going to take longer to fill the bathtub. Okay, so our answer should make sense, right? So again, just think of them in terms of rates, and these problems aren't that bad.